I'm David, and I'm talking about how nature can help us mitigate climate change and how machine learning can scale the solutions nature can provide. So that's the number which scares us. This is the left carbon budget. We have to have a 66% chance to stay under 1.5 Celsius. According to our current emission, we have only seven years and 11 months left until this budget is gone. So nature itself provides a very unique solution. It's probably the cheapest and most natural, by definition, carbon sequestration machine we have. Especially forests, mangroves, and wetlands are considered to be something which we call natural climate solutions that can suck in back those carbon. And actually, that impact is more than you guys can think, actually. It's 36% of all possible carbon mitigation could be done by natural climate solutions. So being able to reforest and help protect nature it's a huge deal. But one thing I really need to say at this presentation is that natural climate solutions are no replacement for immediate decarbonization. As you can see in the graph here, there's no future with fuel from oil and coal. So trees, especially one of the focuses we've been at ETH looking at, has a gigantic potential. Recent studies show that there's still a place for 1 trillion extra trees, and that calculates to be additional 200 gigatons of carbon, which could be captured. But the problem is that instead of planting trees right now, I mean, more and more states are starting. Deforestation rates, the fact that we are burning down trees, have been at the highest in decades in Brazil. The problem with nature is it's a carbon sequestration tool, but it's also a carbon bomb. When you lit up a tree, all the carbon which was stored over several decades come back. And that actually contributes currently to 25% of global emissions, deforestation and land use itself. So this is a map from Brazil. The 80,000 fires from last year's August was the highest recorded in like more than a decade. And that is not just, and that's I think a really big topic to bring up, a math problem. It is actually a human tragedy. Like climate change itself affects first and foremost frontline communities such as indigenous people, and they are right now suffering by that deforestation and also in the future by the increase of temperature. If you look at the incentives why people, instead of planting trees, cut down trees, it's an economic one. Many people in Brazil, 60% of that place is getting deforested in order to raise cattle. Brazil is the biggest beef importer in the world, and farmers are not following a malicious plan, they are just driven by economic incentives to do so. Of course, the United Nations know about that, so there are like payoff schemes already in place in order to prevent deforestation from happening. But one of the problems with that is, so there's, for example, a $25 billion pledged amount from a program initiative called RED+, which is reduction of emission of deforestation degradation, but that money doesn't come in because it's a performance-based payment. So a performance-based payment basically gets only paid out when you can verify that that forest stays, and it verifies that you actually have improvement or there's no damage. And that verification process is really, really tedious. Right now, it's many parts done manually, and you can imagine in the size of the Amazon, that's an impossible task to achieve. And there's also several other like legal constraints which makes the payouts really problematic. So how can machine learning help? One of the big opportunities right now, if you look around, is actually the new space race. People are like getting more and more satellites up there, and so we get a more and more clearer vision of our planet itself for planetary health checks, but also for like commercial purposes. And let's have a clear look at the data. So there are several satellites. The white ones are public ones. That is from NASA and ESA. That has frequencies like 16 days, 5 days, where they take a picture every 16 days or 5 days of a place on the Earth with 30 meters resolution, 10 meters resolution per pixel, and several bands which absorbs lights from vegetation or like RGB. But also commercial satellites have been racing on playing this game and contributing up to a single day per picture of every place in the Earth, with a resolution from 4 meters to 0.3 meters. That's almost enough to see a whole tree. So current existing deforestation alert systems are already partly leveraging satellite imagery and remote sensing. But the problem is that those methods have been developed like several years ago, and back then computation was constrained on being able to modify and constrain the images itself. So we've been looking into, can we maybe use machine learning to directly learn a deforestation prediction on top of the RGB space provided by the satellite images? So what we did is very simple. We cropped out South America, took out like 30,000 images of like 76 meters per pixel, trained a prediction algorithm on deforestation data, which we had over several years, using a simple segmentation network. And to skip over the results, we were basically able to like get a pretty clear view of how it looks like. And to be even more surprising, using only the RGB approach, we saw that on the middle part, this is our prediction. The yellow parts are the deforestation alerts we gave out. On the right part, this is the existing FORMA system, which is currently at state in Brazil. We were able to detect that upper red part, which is ground truth deforestation, while FORMA was missing that. Another opportunity, which is great, is satellite images itself. One of the problems is that there's not a lot of labels, but they have a time sequence. You can imagine them to be like some kind of words. So if you look at a satellite image, you can see deforestation very clearly from your eye without any need of any labels, right? So can we maybe leverage that to learn a better representation of the image? And it turns out we can. Self-supervision provides us with a really powerful tool to leverage unlabeled data sets. So basically, you can imagine a satellite image to be a comic strip where you right now look at the first 3 comic strips and you have to predict how it's going to forward. And that's basically what we're trying to force our algorithm to learn. So our results in that are also, so jump over and see the results here, is on the top, we have, again, this is without any prediction. The middle part is after we train from raw data itself. So upper part is ground truth, lower part is trained only from raw data, how that evolves. And then we used a segmentation algorithm to predict forests on the predicted path, and was able to compare it with the ground truth and see that it misses some parts which are really big jumps in the forest. For example, if you look at the upper right, and the ground truth cuts down a huge part of the forest on the edge, while our algorithm is missing that, and that is due to the big time step that was in between. So we definitely are currently improving this algorithm, and we think more and more data and more training can improve that. And we are right now running a real-world pilot in the Valdivian rainforest together with the government of Chile. And there are so much more opportunities to give you out if you're interested in that space. For example, if you talk about reforestation projects, many of those trees are not growing because they are just planted in, but you're not sure what kind of tree, how you treat it. Planting itself is not enough. You need to also take care of it. So machine learning itself can also help us predict how to take care of that tree and what kind of right soil is for that tree to be planted. On the other hand, we've been also looking into like how to combine low-cost drone images, and which has very high resolution, and satellite imagery to see if we can maybe create even higher resolution maps. Finally, we've been looking into data marketplaces where if your farmer already takes pictures of his farm and trains this algorithm, he should also probably get paid for that. And that could be a possible incentive for providing economic benefits using machine learning. So thank you very much for your attention. If you want to learn more about our research, climateai.org is the platform to go. And I have to thank, of course, my 2 wonderful students who've been carrying a lot of this work, Ming Zhang and Catherine Kang. Thank you so much.
We have time for one very quick question.
Thank you. Last week in Davos, the US President Trump announced that he would launch a trillion tree initiative. Do you know more than us about this? Have you looked into it? Have you heard about the US planting trees?
So they contacted ETH actually to ask for the exact numbers, how many trees they can plant. So, I mean, not us, but like related groups at ETH have been doing the trillion tree calculation. And I mean, it's a number to justify clean coal in his speech, and that's one of the things I really need to raise up and emphasize again. Natural climate solutions are never going to replace, they are not a natural-based solution for continuing to emit, right? So that way that he announced that is, in my opinion, is misleading and should not be taken as an excuse to continue emitting.
Thank you, David.